Welcome back friends. Today we will discuss jump game 6. So let's see the problem statement. You are given a 0 indexed integer array nums and an integer k. You are initially standing at index 0. In one move you can jump at most k steps forward without going outside the boundaries of the array. That is, you can jump from index I to any index in the range I plus 1 to min of n minus 1 comma I plus k inclusive. You want to reach the last index of the array, that is n minus 1. Your score is the sum of all nums of j for every index j you visited in the array. You have to return the maximum score that you can get. So let's see the first test case. Here your nums array is 1, minus 1, minus 2, 4, minus 7 and 3. The value of k is 2. So let's see how we can get an answer for this test case. Let's start from the end of the array. So if we are at index 5, the score to reach to the last index of the array is going to be nums of 5 only. So the score, we will also make a vector dp which is going to store the scores. So dp of I is going to store what is the maximum score to reach to the end of the array from index I. So for index 5, the answer is going to be nums of 5 only. Now let's see what will be the score to reach to the end of the array from index 4. So if we are at index 4, what are the available indices to which you can jump to from index 4? Since the value of k is 2, you can jump to index 5 and index 6, but 6 is out of the bound. So the only available option for you is to jump to index 5. So if you jump to index 5, the score is from index 5 to the end of the array is going to be 3, and since you are at index 4, so you will have to add the nums of 4 with dp of 5 to get the maximum score for the current index, which is going to be minus 7 plus 3, which is equal to minus 4. So from index 4, the maximum score to reach to the end of the array is going to be minus 4. Now let's see what are the available options when you are at index 3. So when you are at index 3, you can jump from index 3 to index 4 or to index 5, but you will jump to index 5. Why? Because if you jump to index 5, you are getting a score of 3, but if you jump to index 4, from there you are getting a score of minus 4. So it is better for you to jump to index 5. So the score for the current index, that is dp of 3, is going to be nums of 3 plus dp of 5, which is 4 plus 3 equal to 7. So from index 3, the maximum score that you can get to reach to the end of the array is 7. Now let's see what are the available indices to which you can jump to from index 2. So if you are at index 2, you can jump either to index 3 or to index 4, but you will jump to index 3. Why? Because it is giving you the maximum score, that is 7. So answer for the current index, that is dp of 2, is going to be nums of 2 plus dp of 3, which is equal to minus 2 plus 7, which is equal to 5. So from index 2, the score to reach to the end of the array is going to be 5. Now let's see, if you are at index 1, what is the maximum score that you can get to reach to the end of the array. So from index 1, you can either jump to index 2 or to index 3, but since dp of 3 is maximum, so you will jump to index 3. So score for the current index, that is dp of 1, is going to be nums of 1 plus dp of 3, which is equal to minus 1 plus 7, which is equal to 6. So from index 1, the maximum score to reach to the end of the array is going to be 6. Now let's see what will be the maximum score to reach from index 0 to end of the array. So if you are at index 0, you can either jump to index 1 or to index 2, but dp of 1 is maximum, so you will jump to index 1. So what will be the score for the current index, that is dp of 0, it will be equal to nums of 0 plus dp of 1, which is equal to 1 plus 6, which is equal to 7. So your answer for this test case is going to be dp of 0, because this is what we want to find, the maximum score to reach to the end of the array from the index 0. So the answer for this test case is going to be 7. And indeed the answer for this test case is 7. Now let's see what will be the time complexity for this solution. The time complexity is going to be order of n into k. Why? Because for every index I, we are exploring at most k, its next k consecutive indices, and getting the best dp value among those k consecutive indices. So for every index I, we are taking order of k time, and we are in total exploring n indices. So the time complexity is going to be order of n into k. But if you see the constraints of the problem, the length of the array can go up to 10 raised to power 5, as well as the value of k can go to 10 raised to power 5. So this solution is definitely going to give a TLE. So we will have to improve this solution. So what we are doing here is, for every index I, we are exploring its next k consecutive indices, and from them we are selecting an index with the maximum score. So if we are able to get this information in order of 1, we can code a solution that runs in big O of n time. So one of the data structure that can help you to get this information in order of 1 is a monotonically decreasing queue. So we will make a dq of pair int comma int, where the first element of the pair is going to store the score to reach to the end of the array from that index, and the second element of the pair is going to store the index. So what we will do is we will initially put the pair nums of n-1 comma n-1 into the DQ, because if we are at the last index of the array, the score to reach to the last index is going to be nums of n-1 itself. So we will put 3, 5 into the DQ. Now we will iterate from index n-2 till index 0, and what we will do is for every index I, we will first see if the pair which is at the front of the DQ, if its index is out of bound, we will remove that element or remove that pair from the DQ. So if we are at index 4, we will first check what is the index of the pair which is at the front of the DQ. So it is 5. Clearly 5 is within the range, since from 4 we can either jump to index 5 or to index 6. So 5 is within the range. So from index 4 we will jump to index 5 because it is giving you the maximum score. So the score to reach to the end of the array from the current index I is going to be nums of I plus the score which is at the front of the DQ. So q dot front dot first. So the score for the current index, that is 4, is going to be nums of I, that is -7, plus score which is at the front of the DQ, which is 3, that is going to be -4. So in this DP vector we are also going to store the answer. Answer for the index 5 is 3. Now we are calculating the answer for index 4. Now we have got the score for the current index. Now before inserting this new pair of score comma index into the DQ, we will remove all the pairs from the back of the DQ which have a score smaller than the current score. Why we do this? We do this to maintain the monotonically decreasing order in the DQ. So we have only one pair which is 3, 5, and its score is definitely greater than the current score. So we do not remove any pair and insert the current pair of score comma index, that is -4, 4 into the DQ from the back. Now we move to the next index. What is the next index? 3. So if when we come to index 3, we first see the index of the pair which is at the front of the DQ. It is 5. Is it in the range? Yes, because from index 3 we can jump either to index 4 or to index 5. So we will calculate the score for the current index. The score for the current index, that is dp of 3, is going to be nums of 3 plus the score which is at the front of the DQ. So it is going to be 4 plus 3, which is going to be 7. Now before inserting the pair of current score comma index into the DQ from the back side, we will first remove all the pairs which have a score smaller than 7. Since minus 4 is smaller than 7, so we will remove this pair from the DQ. Now 3 is also smaller than 7, so we will also remove this pair from the DQ. And now since the Q is empty, so we will insert our new pair 7, 3, and we are also going to store the score in the DP vector. So for index 3 score is 7. For index 4 what was our score? I think minus 7 plus 3, it was minus 4. Now we move to index 2. We check the index of the pair which is at the front of the queue. Is it in the range? Yes, it is in the range. So score for the current index is going to be nums of 2 plus score which is at the front of the DQ. So the score is going to be nums of 2 minus 2 plus 7, which is going to be 5. So before inserting the current pair of score comma index into the DQ, from the back we will remove all the pairs which have a score smaller than 5. Since no pair have a score smaller than 5, so we will insert our new pair into the DQ and also store the answer for the current index, which is 5. Now we move to the next index, that is index 1. Now we check the pair which is at the front of the DQ whether it has index out of bound or not. From index 1, can we jump to index 3? Yes, we can jump. So we will calculate the score for the current index, as dp of 1 is going to be nums of 1 plus score which is at the front of the DQ. So it is going to be minus 1 plus 7, which is equal to 6. Now before inserting the current pair of score comma index into the DQ, we will remove from the back side of the DQ all the pairs which are smaller than, which have a score smaller than the current score. So we will remove this 5, 2, and now after that we will insert the current pair into the DQ. Now we move to the next index, that is index 0. For index 0, first we are going to check the pair which is at the front of the DQ whether its index is out of bound or not. Clearly index 3 is out of bound, because from index 0 we can only jump to index 1 or to index 2. So we will first remove this pair from the front of the DQ. Now we will calculate the score for the current index. The score for the current index is going to be nums of 0 plus the score of the pair which is at the front of the DQ, which is 6. So the score is going to be 1 plus 6, that is 7. Now before inserting the current pair of score comma index into the DQ, we will remove all the pairs from the back of the DQ which have a score smaller than 7. So we will remove 6, 1 from the DQ. After that our DQ becomes empty, so we will insert the current pair into the DQ and also store the answer for the current index, that is dp of 0, which is 7. and before this dp of 1 was 6. At last we are going to return our answer as dp of 0. Solution will have the time complexity of order of n, because we are able to get the best score for every index I in order of 1. So let's see the code for this solution. So what we do is we create a dequeue of pair int comma int. We store the size of the nums array in an integer variable n, and also create a dp vector of size n. This dp vector is going to store the score to reach to the end of the array from an index I, best score to reach to the end of the array from an index I. We initialize dp of n-1 with n-1, because if we are at index n-1, that is we are already at the end of the array, the score is going to be simply nums of n-1, and we push the current pair of score comma index into the dequeue. Now we start iterating from index n-2 and we will go till index 0. For every index I, we first check the index of the pair which is at the front of the dequeue, whether it is out of bound or not. So we check if it is greater than I plus k, we will remove that pair from the front of the dequeue. After that, we will calculate the score for the current index I, which is going to be nums of I plus the maximum score which is at the front of the dequeue. So q dot front dot first, we add this to nums of I and get the score for the current index. Now before inserting the current pair of score comma index into the dequeue, we remove all the pairs from the dequeue from the back side which have a score smaller than the current score, that is dp of I, and we do this process for every index I from n-2 till 0, and at the end we return our answer which is stored in dp of 0. So the time complexity is clearly going to be order of n, because this process is also going to take order of 1, this will take order of 1 time, and this process will also take order of 1 time. Now if we want to observe this while loop, so this in this dequeue, every element is going inside it at max once, and it is coming, and every element is also coming outside from this dequeue at max once. So in total this while loop is going to run order of n time over this for loop. So the time complexity is going to be order of n only. So if we can try to submit this code and see if we are getting accepted or not. Clearly we are getting accepted. So thank you all for watching this video, and please subscribe to my channel if you would like to view more of such informative videos. Thank you.